type 1 and 2 errors and give an example associated to the geometric distribution. In this example, a quality control engineer randomly will continue to sample parts from the production line until the first defective is found. So in particular, this means that there is no fixed sample size. They're going to continue a process until the first success, which is to find the defective, occurs. The engineer is doing this to ensure the proportion of defectives is less than 5%. The inspector will conclude the proportion of defectives is less than 5% if the number of parts inspected is 5 or less. What is the probability of the type 1 error? Okay, so here to get started, we need to state the null and the alternative. The null is that the probability of defective is 5%. What they want to establish is that it's less than 5%, so they're going to continue to inspect parts until they find a defective and record how many parts they have to inspect. The rejection criteria is the number of parts inspected is less than or equal to 5. By definition, this is critical, is that we need to recall what a type 1 error means. It means that we reject the null when the null is true. This means that x is less than or equal to 5 when the proportion is 5%, i.e. the null hypothesis is true. We calculate this with the geometric CDF of it being 1, 2, 3, 4, and 5, and we get it's 22%. That's the type 1 error. Okay. Now, in this example, suppose that in fact the true population proportion of defectives is 3%. So, in fact, the alternative hypothesis is true. We'd like to know what's the probability of a type 2 error if the proportion is 3%. Well, we need to go back to when we talked about type 2 errors. A type 2 error means we fail to reject the null when the alternative is true. Failing to reject the null means that this rejection criteria is false, so x is bigger than or equal to 5 when p is, 0.03%. Okay? So it's going to be given by this calculation. We get 85% is the probability of type 2 error. And so the power test is 1 minus probability of type 2 error. That's 14%. And that means that the 14% represents the probability we correctly reject the alternative hypothesis. Correctly fail to reject the alternative hypothesis. I had it right the first time. We correctly reject the null when the alternative is true. Okay, thank you very much.